My name is Gary Pocock, and this is my Week 9 reflection for the Physics Modelling Instruction course. Right, this week I'm just going to have a bit of an overview of the first two labs and the first two worksheets in the circuits unit, because I found these two worksheets and labs very challenging, and so this is going to be very much a thinking out loud reflection as I try and sort out what I think is going on here and think about how I might deliver this to my students. Because to be honest, I have used the E&M materials before, the modelling materials, but I haven't used Unit 3. I've always been daunted by the complications that are involved here. So I'm just going to try and sort those out in my head. And as I've got down here, I'm going to be focusing a bit on the bulbs and what is going on with the round bulb and the long bulb. Okay, so reflecting on Lab 1, what I thought was that there seems to be a heck of a lot going on here. And it's all going on at the same time, and that's very, very challenging. So I've tried to separate out the different threads, and I felt, well, first of all, there is the story of the fields. That is what's making the charges flow through the wire. And that's sort of, to me, that's the central story and the most important part of the modelling instruction notes, because in the standard presentation of circuits, that's the story that's missing. So I think that's what the main thrust of what the Lab 1 and 2 are trying to get across. But at the same time, you've got these other stories, and my feeling is they're not clearly distinguished in the discussion, and I'm just wondering whether it's possible to separate them out a little bit more and identify more clearly the various threads that are going on here. Okay, so the second story that I've listed is obviously the rate of flow of charge story. So I'm thinking now in terms of the bulbs being connected to the capacitor and watching the bulbs glow as the capacitor discharges. And what we notice is, or our theory is, that the bulbs have a constriction in the rate of flow, and then we also get into the third story. See, I'm having trouble separating out the stories myself, because the bulbs glow because there is an energy conversion happening. And so that brings us to the energy story. And students are obviously going to notice that the bulbs are glowing with different brightness. That is the most obvious feature that students will see, and yet it's something that is not really addressed very clearly in the lab or in the notes. If you look at the teacher notes, for this lab, you'll see that in the post-lab discussion they talk about, and this is the field story and the potential field story derived from the potential story. And then on the next page of the notes, there is no discussion in the notes really of what's happening with the bulbs. And I thought, oh, okay, well maybe worksheet 1 talks about the bulbs, and it does, but only right at the end, and only in this question here. And there's nothing in the lab that clearly articulates what's going on here and gives a clear guide to how to answer this question. So the teacher needs to be very clear, him or herself, and have a good story to explain what's going on. So here is my summary of what's going on in the bulbs when they're being discharged through, when the capacitor is discharging. Okay, so we know about the restrictions. We've determined that the long bulb has a narrower filament, so therefore there is a greater constriction in the long bulb compared to the round bulb. It's a fairly intuitive leap then to conclude that the discharge is going to take longer when going through the long bulb. It will take longer for the charges to flow through the long bulb. That's quite reasonable, and I think the students will accept that. But then we get to the interesting one, the brightness. The long bulb is actually less bright than the round bulb. And that, I think, is not so intuitive and will be more challenging to explain to the students. And obviously the answer is that the capacitor has a fixed amount of energy, and so in both discharges, whether through the long bulb or the round bulb, the same amount of energy is discharged. If it's happening over a longer time, then a smaller amount of energy conversion is happening per second, and that is why the long bulb is less bright. And so my concern was that I didn't think the lab or the worksheet made this connection between brightness and the energy being stored explicit. I think that really needs to be brought out, and so there should be some more questions, I think, that brings that out. And so I felt that this last question on the worksheet, which is the only one that addresses the discharging bulbs. Part 1 says which line represents the discharge with no bulb. That's fine, it's going to be the shortest amount. Which line represents the discharging of the bright bulb? Okay, that's more challenging because then they have to use the energy reasoning to figure out that the bright bulb is discharging the energy more rapidly because of the brightness, and well, the solutions supplied don't really make that connection explicit either. So I guess if I was teaching this, I would be trying to develop some more questions that really draw out these points, and so the students get a really strong feel for what's happening in the two bulbs before moving on. Alright. Oops. Okay, then we get to lab 2, where we're looking at, sorry, just finding lab 2. Alright, again, I'm focusing on the bulb part of it. I really like the early parts of these labs where they establish where the potentials are the same and where they're different. I think that's very well done. But then in step 6 we now get a circuit with a single bulb, and we are using the long bulb. Okay, that's great. But then I think they missed something here, because I really think before jumping into the two bulb circuits, they should have also got the students to replace the long bulb with the round bulb in a single bulb circuit and repeat all the questions again, and so that students can see the difference in brightness between the round bulb and the long bulb and actually try and explain that difference in brightness on the basis of the different constriction in the bulb. So that's my suggestion. Step 6 should analyze both a single bulb circuit with, a long bulb circuit and a round bulb circuit as single bulbs in the circuit. Do that first. Go through all the questions and in particular address the brightness. I know that's an energy story, it's not so much the field story, although it's obviously involved, but I think that it's such an obvious difference that the students really need to be clear about why that is happening. And of course the answer is that the round bulb has a lesser restriction, and so the rate of flow of charge is going to be higher through the round bulb, so energy is converted more quickly. So we're at the point now where we've seen two situations in which the round bulb has been brighter than the long bulb, and students could easily reach the conclusion that the round bulb is always going to be brighter than the long bulb. Big surprise! Go to the two bulb circuit and the long bulb is brighter than the round bulb. And again, my concern is that this surprise is not really addressed in the notes, and it's such an obvious thing for the students to notice that I think it really does need to be addressed. So why is the round bulb why is the long bulb brighter than the round bulb? Well, let's go. So I thought, okay, let's go to worksheet 2. But worksheet 2 jumps straight into the two bulb situation. Two bulb in series and then two bulb in parallel. I'm focusing on the two bulb in series because that's the one that produces the surprise, the long bulb being brighter. And I thought here worksheet 2 really should have included a question with the single bulbs circuits first and then move into the series bulb. So I did something like this. Let's look at single bulb circuits side by side and work our way through exactly the same questions that are in worksheet 2 for the two bulb circuit. And that means students will have to directly address the issue of the brightness of the bulbs in the single bulb situation first, before confronting the issue of brightness in the bulbs in a two bulb circuit. So I think that's one way of making things a little bit clearer. Oops, that's next week, sorry. Alright, so that's the main thrust of my reflections for this week. As I said at the start, I find these labs quite challenging, and I'm still trying to work through how to separate out these threads and present them in a coherent and logical way to the students. Before, my traditional way of doing this, which is obviously not modeling instruction and hasn't addressed the microscopic story in terms of fields. And what I've also done is I've tended in the past to use identical bulbs, at least initially in my circuits, just to introduce students to series and parallel circuits. So I'm quite intrigued with the idea of actually using two non-identical bulbs right from the get-go and analysing the differences between those two bulbs when you have series and parallel circuits. I think that's a good idea, and I will definitely be doing that in future. Of course, the other thing that sort of is in the background behind all this, which is not really explained, is the transient phase, and that's something that I puzzle about the whole time. How the flow gets going in the first place, how the charge piles up at the constrictions. That's implicit in everything we do, but we don't really spell that out.